And I didn't do this on purpose, but it was a really good joke after the fact. Well, I guess sort of. But I must have missed. There must have been somebody withdrawn from the class or something like that. So there, as I was going down, bubbling in the grades, I gave probably the best student in the class an F in the class, which then means that everybody after that was a roll of the dice, whether they got the right grade or the next guy, the next person's grade. He was the only one that complained. He's like, how bad did I do in the final? And I said, hey, all grades are final. I did change it, but I required a 20-minute walk to change grades back then. I had to go all the way up to the hill at the university and go into the registrar's office. You had to fill out all this paperwork, and now you just send a quick email and it's done. Okay. Okay, so all the quizzes are graded. So I do apologize for the last minute switcheroo there. That was an unfortunate but unavoidable situation. It worked out fine in the end, but it was unavoidable. So on one hand, couple positives actually. Everybody in the entire class did do the quiz one way or another. A couple of them were late, but they had messaged me, and I basically just, if you submitted it, I graded it as is. I didn't count anything as being late because I know some things were a little bit confusing. So a couple lessons to learn from here. Make sure everybody's on Slack. I think actually wasn't that like a unofficial at the end of a class homework assignment, maybe first or second day of class, when I said, make sure you're on Slack for next class. I make a lot of announcements on Slack, but it's not just that. It's not just when I'm making an announcement. We also put up things about like internship opportunities and things like that. Slack is the tool that the department uses for communicating with the students. We won't always send emails about things. So this was good practice for that. So for, yeah, my understanding was I got a Slack message from somebody who kind of said that basically everybody showed up to class, which meant that very few people check Slack. So use that as a lesson. Download Slack for your phone. You get a notification just like a text message. Remember, you got to go to cuwcs.slack.com, and then you enroll with your cuw.edu email, and that will let you into it. And then you go and join the Slack channel by clicking a little plus sign next to channels and going and finding CSC200. And make sure you set up notifications for 200 to notify you for all messages. I think that's actually the default, but double check that. That way, whenever we put something out there, you'll get a notification. A lot of students, you can create your own private channels on Slack as well. So it's pretty common for students when they create study groups or something like that, that they create a private channel on Slack for their study group. So you can ask questions even when you're not like meeting with each other. So lots of good uses for it, but do make sure that you have access to it. But bright side is everybody did do the quiz, which was good. I kind of expected there to be some non-participation situations. Grades on the quizzes was actually pretty good. Class average was about a 90 on the quiz. I mean, there were points missed here and there. So if you scored substantially lower than that, you know, not necessarily if you got like an 80 or something like that, but I mean, if you got like a 30 or a 40, that means there's some concept you're drastically missing. Maybe one of the things I'd point to is the third question was a programming question, and people answered it. A couple of people answered it as a number conversion question. I'm not sure how that worked, but that didn't earn points. But one thing I did want to go over just was the first question on the exam, and then we can actually look at the third question on the quiz as well. But most people got the third one right, just fine. But I will use it as a quick example. But remember when we spent that entire class on number conversion stuff, right? And near the end of class, I talked about the trick. We talked about that idea of why octal and hexadecimal are so important in computer science. It's because of their compatibility with binary. So me asking you to go from base 16 to base 2, the implication was to use the trick, not that you had to. So many of you converted it from hexadecimal to decimal first. Then you went from decimal to binary. You'll get the right answer. That's not good, but it just takes a lot longer. So some of you that got the wrong answer at the end, but you started off showing me your work, just show me the decimal version of it, and your decimal version was wrong. So somewhere in your conversion going from hex to decimal, you messed up, even though your binary conversion off that decimal number was accurate. And you didn't lose crazy points, but you know, that was the scoop there. So let me kind of go through the intended way of doing this. So with hexadecimal, which is base 16, we can represent every single hextet, 0 through 9, A through F, using exactly 4 bits. All right, so 3, A, B, 3 is the same as 3, 10, 11, 3. So now the 4-bit representation of each of these is 0, 0, 1, 1. That's a 3. So this is the 1's place, the 2's place. 2 plus 1 is 3. So this is the 4-bit representation of the number 3. For a 10, 1, 0, 1, 0. So this is 1's, 2's, 4's, 8's. This is 1 in the 8's place and 1 in the 2's place. That's a 10. For an 11. And then our last 3. So our final answer is that guy. And it's still accurate to leave the first leading zeros off. They don't change the value. But this probably would have been the most direct way of presenting your answer. So what we're seeing here is that example of why hexadecimal is a popular base related to computers. It's because you can fully represent all of the hextets in exactly 4 bits. Now you might say, well, why not base 17? Well, base 17 will require 5 bits and you will have wasted representations of those 5 bits. So your next base that is very compatible with computers would be base 32, because then you would use 5 bits to represent all of the possible values of base 32. Okay, similarly, base 8 can be represented in 3 bits. And base 4 can be represented in 2 bits. All right, so questions about this one. This was the intent for that first question. Even if you still got all the points if you got it right going the long way. Go ahead. You don't have to. You can, if you really wanted to convert this to, you could just do the divide by 2 thing and get the right answer. Yeah, you don't have to memorize these, but a 4-bit binary number is pretty easy to kind of go through. This is the 1's place, 2's place, 4's place, 8's place. So this is an 8 plus a 2 is a 10. 8 plus a 2 plus a 1 is an 11. Yeah, so you certainly could. But I think these are small enough where you can kind of just mathy it out on the fly. All right. Then the last question. Let's create a new project here. All right, the last question asked you to write a loop. So do something some number of times. So I said loop through all the values between 100 and 200. So for int I is equal to 100, I is less than. You could have said less than or equal to 200. I didn't necessarily make it clear whether I wanted you to include 200 or not include 200. That didn't make a difference. So we're going through all the numbers between 100 and 200, and for each one, we're asking the question. If it's even, we want to print out the word even. Otherwise, we're going to print out the word odd. So if the current value I, when divided by 2, has a remainder of 0, if it's even, see out even. Else, see out odd. Good. No, I didn't say print out the numbers, but it wasn't wrong. As long as you gave me even and odd, it wasn't a problem. Common mistakes on this one was I specified go from the numbers 100 to 200. So it was common that you fell into the pattern of going from 0 to 200, something like that. Not the end of the world in the big scheme of things, but I wanted you to show me that you understood in a for loop that this is the starting point, this is how long I go for, and this is how I change that counter each time through. So specifically, the question was go from the numbers between 100 and 200, not 0 to 200. All right. If you printed out the numbers as well, you got the points. It's fine. But if you didn't print out even or odd, you would have lost some points, because otherwise, let's say you just printed out the number in here. If you did that, now I'm getting literally every number between 100 and 200. Even though you're asking some questions about even and odd in here, you're doing the same thing regardless of your answer to that question. You're just saying, hey, if it was even, print out the number. If it was odd, print out the number. Here's all the numbers. All right, so this is what I was looking for that guy. Or something, along those lines. Some folks wrote it as two separate for loops. They wrote a for loop that went through 100 to 200 asking if it was even, and then they wrote a completely separate for loop just asking if it was odd, rather than doing an if else inside of a single loop. Technically, you did answer the question. I didn't necessarily say they had to alternate. You gave me all the evens and all the odds. But I probably would have made a comment on the quiz indicating that, you could have accomplished this in a single loop. All right, so questions about this guy. Okie dokie. And like I said, good participation. Generally, class did pretty well on this from just a off the cuff quiz thing. Like I said, the class average was a 90. So if you did substantially worse than that, go through and kind of look at where your deficiencies were and go and learn those things. I think the low scores maybe like a kind of a 30% or so, and that was probably missing most of the points on one or two of the questions, something like that. Okay, next thing, homework for today. And this was actually a good one based on some of the questions I got. This wasn't meant to be a difficult assignment, but the questions that it elicited were actually good ones. So one question I got was something along the lines of, did we already learn in class how to do this? Now, it actually is a good question because it goes back to something I said earlier on. What we're learning in here is the fundamentals. We're learning some individual little magic tricks, things that we know how to do. So kind of like learning a sport. You learn how to do the fundamentals of that sport. Then during game time, you put those fundamentals together to actually solve the problem. Okay. So, you know, if you learn how to hammer a nail and you learn how to turn a screwdriver and you learn how to use a level, something like that, all of a sudden you can now maybe using those skills, you don't have to use all of them, but using some subset of those skills, you can now hang a picture. Okay, even though I never actually taught you to hang a picture. That makes sense? You hammer the nail, you put the picture up on the thing, you use the level to make sure it's level. So you've learned individual skills that you can now apply using human problem solving to accomplish the task you're trying to accomplish. Okay, so to solve this problem, you did have all of the necessary tools to solve it. But this goes back to, I probably gave you some sort of example. Actually, it was back in the, when I first explained why we were using C++ in here rather than a language like Python, even though all programming languages are the same. If you go and do a Google search for how do I solve my homework assignment in Python, there might be a solution out there to stuff because Python has a whole bunch of shortcuts to different things in it, where there's going to be far less things just available out there in C and C++. But I don't want you to rely on Google, right? If you're in if you're playing a sport and you know it's competition time, you don't go and get somebody else to come and take your place, right? You rely on your fundamentals that you've been practicing, and you're going to play as well as you can play and let the chips fall where they may. Does that make some sense? Okay. So write a program that displays to the screen all the numbers between 0 and 9. Display these numbers on 100 consecutive lines. Submit a link to the code. Okay, so we're displaying to the screen all the numbers between 0 and 9. Let's look at a couple of ways we could accomplish that. Okay. So the way that I did not intend for you to do it, but you could have done it this way, is that that does display to the screen all the numbers. Well, let's just start with this. We're breaking this problem down into little tiny steps, right? All we're solving here is display the numbers 0 to 9 to the display, to the screen. All right, so you can accomplish it this way. So there's the numbers 0 through 9 to the screen. Oop. Oh, and Dell, thank you. So there's 0 to 9 to the screen. Similarly, you could have said for int I is equal to 0, I is less than or equal to 9, I is equal to I plus 1, C out I, and then at the end you can say C out and L. That'll kick it down a line. So this will go through 10 times. Each time through, it'll display a 0, then a 1, then a 2, then a 3, but it won't press enter at the end of it. So this will show them all right next to each other. So either one of those things does accomplish displaying the number 0 to 9 to the screen. Make sense? Now, my intention was for you to maybe write it this way, but this way is not incorrect. Either one of those is fine. Now, I want to display this 100 consecutive lines. So I want to do what I just did 100 times. Where I is equal to 0, I is less than 100, I is equal to I plus 1. If you wanted to do it this way, that will display all the numbers 0 to 9 to the screen 100 times. So there's the answer to the homework. Go ahead. No. This is one of those things back from the beginning where since main, I think I changed it in our previous thing. Old school C programs were running in Unix. We didn't have a graphic user interface, so you might want to know whether the program worked or didn't work. So that's why main up here, all programs begin and end with main, returned an int. You can have it return void these days and then not have to have that. So that's actually not part of our logic. That's just part of the structure of a C++ program.
So I basically just did that, but I still had.
If you put int main, that's fine because it doesn't require you to return it. It'll still work. I'm saying, hey, I'm allowed to return the value. In fact, we just saw that C++ requires main, which is a function. And this will make more sense after today's lesson when we start writing our own functions.
So basically that's exactly what I did.
It's fine. Yeah. I think the return 0 thing, that'll probably make more sense after we talk about writing our own functions today. So up to this point, let's just say that's the way it works. And if you happen to notice, if you leave that off, it still works, that's okay. Just assume it's magic for right now, but all that gets explained today when we write our own functions and what that is. Okay, so this is one way you could have accomplished the assignment. My intention would have been for you to accomplish it this way, with one caveat, is we would have had to use a different counter inside because we already are using a variable named I. So now we have a nested for loop. We're doing something 100 times. What are we doing 100 times? We're running this code. 100 times. This is the task I'm doing this many times. It just so happens that this task is another loop that goes through 10 times. And then at the end of doing that 10 times, we kick it down the line. That's what cout and L does. It's like presses return. This will give us the same output. That makes sense? All right, so hopefully going through this today, you see that it's not that we ever learn to display something to the screen 100 times. Specifically, it's we learned how to display something to the screen, and we also learned how to do something some number of times. Now we're putting those two skills together and displaying something to the screen 100 times. We want to get practice at breaking problems down into those smaller steps like that. All right. And it's supposed to look trivial when we get to class and be ready. It's like, look, I spent 4 hours on this stupid assignment. That? Are you serious? That's the process. Okay. All right. Questions about this? All right. So let's see. I was gonna show the even odd thing already from the quiz. Go ahead.
Not the I, but the J.
Mm-hmm.
If you were to put J is equal to not equal to 9.
You want to say this?
Yeah.
Well, because the Boolean, well, it'll run. It just won't give you the output you want. Because this says start J off at 0. Keep going as long as J is equal to 9.
Okay,
Is 0 equal to 9?
no,
Nope, we're done.
so what was so what could I put in there to say do it until?
Well, you could say less than or equal to that, or you could say less than 10.
Okay, or what, okay.
But understand the mechanics. So because this is a good question, it's completely related to what I just said. Let's put back in the wrong thing here, right? A for loop says this is your starting counter.
Okay.
Keep going as long as this Boolean expression is true. Boolean expressions, any expression that boils down to a single value of true or false. A loop says we're going to start with this. We are going to keep looping as long as this is true. And then we're going to execute the body, and then we'll make our change.
So
This guy is not true even the first time. 0 and 9 not equal to each other. We're done. We do nothing. The output of this for loop is absolutely nothing.
I did, it was one equals. And it came up with a 9.
Oh, this guy? What's the single? You wrote it like this?
Yeah.
Okay, what's the single equal sign? Which operator is that? Double equal sign is our equivalence operator. What's the single equal sign to? Equal to? The assignment operator. So what are we doing here? We're starting J off at 0. This guy isn't even a Boolean expression. This guy's setting J equal to 9.
Gotcha.
So I would presume this would give us an error. Oh, interesting.
Yeah.
That actually proves the point. Oh, it won't give us an error in this. I think when we talked about Boolean expressions, I would have mentioned that a newer language like Java actually treats trues and falses non-mathematically, even though it's stored as a number. In C and C++, this is a Boolean expression because the Boolean expression is any expression that boils down to a single value of true or false. And technically, J is equal to 9 boils down to the number 9. Okay. And what you're saying, well, 9 is not true and false. False is 0. True is anything non-zero. Typically, we think of it as 0 and 1. Okay. But it's anything non-zero. So by us setting it to 9 each time, this is basically always true. Because 9 is true, 9 is true, 9 is true, 9 is true. Because it's non-zero. It's not false. It must be true. So then we're printing out J. Because we're setting it to 9 each time. That makes sense? So something to be careful of here is when you're using the equal sign, the double equal sign tests for equivalence. The single equal sign is the assignment operator. And actually, this is a good example, maybe why we use C++ in here. In Java, this would have screamed at us. In here, it at least says, okay, that is strange output. Why are we getting that output? It makes us go back to the code and start questioning, why is it giving us that? And trying to understand how Booleans are actually represented under the hood. This goes back to an earlier lecture where we basically said computers represent everything as numbers. An int is a number. A char is a number mapped to either the ASCII or the Unicode character set. A Boolean is under the hood represented as a number, 0 versus non-zero, or we typically think of 0 or 1, but we're seeing right here that anything that's not 0 is presumed to be true. Booleans are treated as numbers in C++. We can even do math with them. That doesn't make a lot of sense to do math with Booleans, but we could do math with Booleans because it just happens to be represented as numbers under the hood. Java gives us a layer of protection and says, hey, yes, we promise you under the hood, they're represented using numbers, but we went ahead and put some mouse traps around it and said, if you try to do something with this that you probably shouldn't be doing, we'll scream at you for your own protection. So we might say, and this is the backwards thinking, we might say, well, as beginning programmers, we kind of want to have extra protection. Yes, but that also is not necessarily the best way to learn. You kind of need to step onto these mouse traps a little bit, because one of the skills we learn in here is that debugging skill. And also going back and reviewing our code and saying, what is the code that I wrote actually do? Not what did I mean for it to do, but what does it actually do? All right, those are skills that are going to help you learn, because we learn a lot more from our mistakes than we do from our successes. If you sat down and wrote this assignment correctly in 15 seconds, that's fine. You probably came into the class with an existing programming skill set, no problem. You didn't need to learn this skill, but eventually we're going to bump into a program that's complex enough for you where you're not going to be able to sit down and solve it in 15 seconds. And then you'll start making your own mistakes. You'll learn from having to correct those mistakes. You don't learn a whole lot by just getting it right the very first time. Okay. So questions about this guy? Here, I'll put it back in the previous form.
So if you wanted to go to, if you wanted it to go from, let's say, 0 to 8, you could put greater than 8 or greater than 9.
Less than 9.
Yeah.
This guy.
Yeah.
They mean the same thing.
Gotcha. Okay.
J less than 9 is the same thing as J less than or equal to 8.
Okay. Gotcha.
Yeah. And that's not a programming thing. That's
Yeah.
just a math.
Yeah.
That's what a math thing is.
I was trying to think of the way that you've done that before.
Yep.
So that's the way that.
All right. And all those little things that goes right back to the idea of reps. Put in the reps, put in the reps, put in the reps. You should be spending, I would expect most of the students in this class, since we assume that you have no programming experience coming into this class. And I told you day one, programming is hard. So I would expect that many of you are spending at least an hour, if not more, solving something like this. Even though in the end, the solution is trivial. In 3 weeks, you'll look back at this and say, why did that take me any more than a minute? Because you'll have a new type of problem that will take you an hour or two to solve. And before you know it, you're like, I'm a whole lot better than I used to be, but I still am spending an hour or two on my homework assignments because they keep getting harder and harder and harder. I promise you, it'll work out once you see your bank accounts later on. All right, put in the reps now. It will work out. And believe me when I tell you that this debugging skill, making a mistake, going and investigating your code and fixing it, that's where your learning is actually taking part now. That is where you want to be spending most of your time. Even though it sucks, even though you want to have a life and not sit there spending time doing your programming assignments forever and ever and ever, it will pay off, because this is a hard skill and it'll end up being a superpower because it's something you'll be able to do that a lot of other people won't. And that'll get you paid good money to do something that is a God-given gift. All right. Having said all that, let's look at our next skill. So we're going to add something else to our toolbox. Functions. Sometimes we want to write a chunk of code that takes some inputs, performs some operation, and then spits out a result. Ideally, we can then call this same chunk of code multiple times with different inputs and potentially get different results. And this is something that's related to real life. We like to have little machines that do stuff for us. At our house, you might have a toaster where if you put 2 pieces of white toast in there and press the button down, you get toasted white toast. If you walk right up to that same toaster and put 2 slices of rye bread in there and push the button down, you get toasted rye bread. You put 2 Pop-Tarts in there, push the button down, you get toasted Pop-Tarts. Okay. This thing toasts stuff, but you can give it different inputs to do that job, right? Rather than having to reinvent the wheel every single time you wanted to toast something, you're getting out all these extra tools, basically having to build all the components of a toaster to apply heat to both sides and all that stuff every single time you want to toast something. You buy the toaster once, you use it till it breaks. Okay. That's the concept of functions. We've written code here that does something one time. And if we want to make changes to it, that's not a problem. But we now make those, we have to make those changes in line with the code we already had. Let's go back to what we have today, where I said, we're going to do this. Let me switch it back to 9. So now it's 0 through 9, 100 times, right? This exact code right now does this exact number of times. What if I took all of this code and I wrote a function? Let's call this guy do something. And he takes a single input as a parameter that's of type integer, and we'll call it number of times. And then what I'll do is inside of here, I'll replace that hard-coded 100 I had with number of times. Whatever value was passed in, that's the number of times I'll do this. I've built my own toaster, except instead of toasting toast, this guy displays the numbers 0 through 9 to the screen some number of times. Highly useful skill. Okay, we got it on sale at Target. All right, so now what I can do down here is I can call my do something function, and initially I'll pass it 100. And there's my same output. But if I decide, you know what, I only want you to do it 5 times. Now I get it 5 times. But now I could say, you know, do it 5 times, then in a separate call, do it 1,000 times. I'm using my toaster twice. Once to do it 5 times, once to do it 1,000 times. We're not going to notice the difference because it's just going to be a wall of text on there, but I promise you, this just happened 1,005 times. Go ahead. Yep. So this guy right here, this is our ability. When you go to Target, you buy that toaster and you never use it, that was an untapped resource, a waste of money, right? All right. Not until we actually put the slice of bread into the toaster does it do its thing. So in this case, I'm calling my function called do something. This function expects me to give it an integer. Okay. It expects one of these guys, and it's going to call it number of times. Whatever, so when I pass a 5 in here, 5 will get associated with number of times. So in the logic in here, anytime I say number of times, it'll get replaced with a 5. In the second call here, 1,000 will get passed in as number of times. So whenever I say number of times in here, it'll replace it with 1,000. Go ahead. It's the return type. We'll talk about that in a second. Yep. Go ahead. You mean, does it matter where I put this? No, Well, I mean, now I'm just calling an ability. I mean, I can print something before that. Well, no, I mean, you're asking where inside of main do I put these? Doesn't matter. Basically, you can use your toaster whenever you want. Whenever it makes sense to call your function, you can call your function. Because really what's happening here is this guy is going to turn into this code with all occurrences of number of times replaced with 5. So whenever we would have that, that's where we would put it. So there is no rule of where we can put it inside of main, just whenever you need it. Yeah, okay, that's why I thought you were originally asking. That's why I said, you mean where to put this? All right, so it's a good question, and let me show you the problem. So let's go ahead and let's put it after this guy. And I believe this is going to give us an error. If it doesn't, I'll force it to give us an error with an older version of C++. So this is what you were asking. Could I put main before this guy? All right, so if we think about this just logically as people, I say that all programs begin and end with main. Okay, as we're walking through here, we hit something called do something. We don't know what it is. Now, as a person, we can glance down and say, oh, well, here's do something. It's right down there. Okay, we know what it is, right? The question is does the C++ compiler know what it is? In most modern languages, this would be fine. Even in more recent versions of C++, this would be fine. But it's the rationale behind it. So I hope this gives us an error. It does, good. So do something was not declared in this scope. Programs begin and end with main. So when I hit run here, it started right here, line 1 of main. And what did I say to do in line 1 of main? I said call do something. And up to this point in time, it's never heard of that guy. All right, because this guy was defined down here. Now, our natural fix, we just saw it run a minute ago, is, oh, well, just put it up above it. Problem solved. And we might say most of the time the problem is solved. But just as I can write functions that I call from main, we can write functions that get called from other functions. So you could run into a situation where you have 2 functions that are reliant on each other. They both call each other from within those functions, and now you have a chicken or the egg problem. How does this guy compile if he's reliant on this guy, and this guy is reliant on this guy, but this guy doesn't know about this guy? We got a problem. All right. So in older languages like this, what we do is we do something called prototyping. So what I can do is at the top of my code, I can say, look, you are going to somewhere in here find a function called do something that takes in an int. And actually, you don't even need the number of times in here. You can just say this. He's called do something. He returns nothing. We'll talk about that in a second. And he requires an int. I promise you, I've defined him later on. But now by doing this, I've made him part of the scope. So I've just let the compiler know this guy will exist. So when you bump into it in here, don't be surprised. Even though I have not implemented it yet. So now we fixed that problem of having functions that are reliant on each other, because up to this point, if I have 5 functions defined, even if they're reliant on each other, I haven't written the code yet that makes them reliant on each other. I've just let the compiler know that, hey, I'm going to be defining a bunch of crap below. I have no idea what order I'm going to do it in, but you're going to find it down there. So here's just the, FYI. All right. So this is called function prototyping. As we get to object-oriented, we start doing classes. We'll actually create a secondary file for our programs called a header file, where we'll put some stuff in that header file, which effectively is what we're currently prototyping up here. All right. So we might say that the cleanest way to always do this is prototype all your functions at the very top, and then you can implement them in whatever order you want later on. I typically, and this kind of goes back to your original question, I typically will always have main at the top of my program, preceded by any prototypes, and then implement those prototypes later on. Just so at the top, I don't have to run through 10,000 lines of code before I finally get to what my program does, since all programs begin and end with main. Go ahead. Can you implement, so you want to do this guy, right? All right, so starting point is no. Okay, you can't implement a function inside of a function. The reality is that's slightly a lie. The correct way of saying it is you can't implement well, in C++, it's the truth. But in some of our more modern languages, the real way of saying it is you can't implement a named function within another function. We have these things called, if you've ever done some JavaScript stuff, callback functions, or the formal name of these guys is closures, where effectively it doesn't have a name, but you have something that takes in this, and it's what I want you to call when something else finishes. That's a reality, but not something that we want to be concerned about at this level. So our answer to your question is no, you will never write functions inside of other functions. Yep, functions live outside of other functions. You just need to make sure that C++ knows about the function before you call it. Either write it beforehand, or probably the better rule of thumb, kind of along the lines of the always use curly braces suggestion, which hopefully I mostly on the quiz gave you feedback for this, but many people didn't use curly braces on the quiz, which I get it. You're not necessarily using a compiler and stuff, so it's not the end of the world, but always use curly braces. It will help you make less mistakes. Okay. But so along those lines, I might argue that always prototype your functions. This is its name, this is what it takes, and this is what it returns. And we'll look at that return thing here next, because void means it's not going to return anything. This guy right here, he does some stuff, but he doesn't spit out an answer. Make sense? He's not actually producing a product. So this is like, you have your toaster at home. We put our 2 pieces of toast in, we push the button, we expect it to give us back toast. All right, it's returning a value to us in toast, as opposed to the garbage disposal, where we throw something in there, we hit the switch, we call upon the garbage disposal. If something comes back at us from there, we've messed up. Something we made a mistake. Okay, so we expect the garbage disposal to perform a task, but not actually give us a result back. Make some sense? So what we've done here is we've written a guy that's kind of like our garbage disposal. Do something, in this case, it's printing stuff to the screen. And this is a note to take down. There is a difference between displaying something to the screen and returning a value. I'm going to show you the opposite side of it right now, but that's an important concept. Returning a value is different than displaying a value. So let's go ahead and write a second function. So this function is going to return an int. We're going to call this guy add nums. And we'll have it take in an int A and an int B. And I'm going to go ahead and go back here. Even though it's not required, I typically will write my prototypes to exactly mimic what I intend to be implementing later on. I usually put the variable names in there. So this is saying I will be writing a function called do something that returns nothing and takes in an int number of times as a parameter. I intend to write a function called add nums that returns an integer that takes in an int A and an int B. Because that way I can just go and copy that piece of it, come down below main, and now I can write that function. All right, so I just copied this, went down below main because I like to have main near the top, paste that in, and then just put an opening and closing curly brace in there. So now I'm ready to make my sandwich, write the logic of this guy in here. All right, and given its name, this particular function's job is going to be to add some numbers. In this case, I'm passing it two numbers, int A and int B. I wanted to add the numbers together. So maybe I say int sum is equal to A plus B. So now I've created a variable. I didn't have to create a variable here, but I chose to. Well, I'll show you the alternative here in a second. But I said, you know what? I want to remember something new. I'm going to call it sum. And what I want to remember is whatever A is plus B, whatever B is, I want to add those together and I want to remember that answer. All right. So at this point, I've done something. At this point, I've still just done something. Okay. This is what add nums currently does. I'll go ahead and not call do something here. So I'm going to say add nums 5 and 7. We'll go ahead and run that. And we get a 12. Okay, that's what 5 and 7 is. But add nums, I advertised as something that is going to return an integer. It's going to actually spit a result out. I didn't mean to print it. This is different than returning a value. I'm going to go ahead and return the sum. I did the math. I stored the result in this variable. And then I said, I want to return whatever that value is. It's going to come flying out of there as an int. So what's the output of this program going to be? I'm asking what the output is, not what does this program do. It's not going to display anything. The output of this program is nothing. I still did something. Program is begin and end with main, right? So what did I do? Well, I called upon my add nums function. I passed it a 5 and a 7. 5 and 7 got passed in here. I added them together, storing the result in sum, and then I spit sum back out. I returned the value of sum. What did I do with it up here? Nothing.
But you can go up there and say,
I can do that. Now I did something with it, right? I caught it. Now, if I run this program now, it's still going to have nothing. No output. I'm still doing some stuff. In fact, now I'm doing a little bit more. Not only did I call add nums, I also was ready, like in baseball, a catcher. I was ready to catch the result. The result came out. I caught it inside of answer. But now if I want to actually see the answer, if I want to have output, that's when I could call it directly.
okay.
So now I'll have my actual answer that came out of this guy. Yeah, answer. Thank you. That seems to be a mistake I continually make, doesn't it? Of course, doing it on purpose. You have examples of when you're prone to make certain mistakes, then you'll pay more attention to it. But I have an audience that's I'm testing you, so you scream at me when I make a mistake. Because sometimes I do that. I put little syntax errors in there really to test your debugging skills. Because of course I've never made a syntax error.
Yeah.
I'm waiting for my first one. I expect it's going to happen eventually. Yeah. Oh, this guy, let's pretend nothing for right now. But once we have some more advanced programs, it will allow us to step through our program kind of step by step and see what the current value of variables is. So like we would see, what is A equal to? What is B equal to? What is sum equal to? Without us having to put a bunch of print statements out. Like let's say we have a program with 100 lines of code in it, and we're getting the wrong result. And we go back through, we're wondering, okay, where did we go south? We might go and print out variables at different points in time in there and say, okay, well, what is it here? And then I do some stuff. What is it here? Like, oh, it changed. This is the problem, right? The debugger keeps us from having to do a lot of those print statements because it will show us those values as we step through our code line by line by line by line. Oh, let's see. I've never used the debugger in here. If you're new to debugging program, blah, 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 whatever. All right, so we'll go ahead and tell it to start. Oh, we need to put break statements in here. So what's our, can we break here? Okay. So I'm telling it to stop the program right here. So I'll go ahead and hit start. It ran to this line of code. Currently answers has nothing in it, right? Because I haven't run add nums yet. So I'm going to say step into, which will step into add nums. So it stepped into this function, which now puts us down in here. So now I'm inside of add nums. Add nums is right here. I'm going to step, let's see, I'll step over because I wanted to get to over this line. Now I'm in the sum line. Now notice here, where's my A and B? Does it show me A and B yet? So there's my sum is 12. I'm trying to see where does it show me A and B, because this A and this B are not the right values because those are the default ones. But it should show me what was passed in at some point. Let's keep stepping over. That hits the end of this guy, which should put me back out here. Step over. So now I've finished running this line. So now I'm sitting on this line. Notice that answer is now equal to a 12. And now I'm calling C out on answer. So if I step into this, it's going to jump into the function called C out. I'll be looking at somebody else's crazy code. So I'm going to step over this and get the result of what C out was. So there's my 12. And then if I step over again, I hit the end of the program. And I can ultimately hit continue if I want. That makes sense? So it allows you to walk through it line by line. In a simple program like this, it's not really a thing. Although I am interested in why A and B, it didn't show me the values that were passed in, the 5 and 7. That seems to be, let's call it bad. When I step into here, when I get to add nums here, A is a 5 and B is a 7. So I see it right here. We stepped in to add nums. This seemingly is showing like default values for that. And I don't see 5 and 7. Yeah, I wonder if they meant to like expand something over here to show me those, or if I'm not expanding something. I would have expected, based on the syntax here, or based on what I'm seeing here, that it would have said A is 5, B is 7 in here. Even though we'll prove to ourselves right after the next line that we did in fact get a sum of 12. So it had the right numbers. It just wasn't really showing me those right numbers. Keeping in mind that this is a full IDE built in a web page. So maybe there's some sketchiness happening behind the scenes there. Yeah. I would say the reality is related to this is that you probably won't use a debugger for a while. In fact, I would even say that I would encourage you not to use the debugger initially, because I think there is a real skill in being forced to walk through your program and putting little print statements in different places to kind of investigate what's the value right here, what's the value right here, what's the value right here. Even though the debugger is supposed to be a tool that kind of automates some of that for us, I think there's value in doing it by hand. especially in this case where, I mean, it's possible that I'm just missing something, but in this case where it seems like it's not necessarily showing me the value of everything. I would think it would be pretty handy to know what my values of my parameters for this function are when it was called. So then you click here. Well, maybe it's a right click. No, we're just done. This is our new life. Do I have to just hit stop? I doubt it, because I think that's probably what we stepped into. But yeah, but that's what we just did, is roughly how debuggers work in almost any tool. You put breakpoints at various places that you want to kind of make sure the program pauses, then you can walk for a little bit, and you can have multiple breakpoints, and you can hit continue and run to the next breakpoint and then walk for a little bit. All right, so we have add nums here. We pass this guy a couple of values. It sums them together, returns the answer. Now, we didn't actually have to store this inside of a variable called sum. We could have just returned the sum of those two numbers. Could have just done that, because when this function ends, sum was a variable that was born inside of this function, and it's going to die when this function ends.
So what about return sum?
Yeah, this return statement makes a function immediately end.
Okay.
So when it ends, it's going to return whatever the value of sum is,
So,
and that's the point when this guy dies.
okay, could we go up to that C out and say sum instead of answer?
Okay, so you want to say sum here.
Yeah.
Okay, what do you think the answer is going to be? Do you think we're going to be able to do this?
Probably not.
We pretend like that code down there, we don't see it. Do you see a variable here called sum?
No.
So there isn't a variable here called sum. It's going to yell at us and say, I don't know about that variable. Sum was not declared in the scope, because sum was actually declared in this scope. And this scope only existed as long as we actually had that toaster out and was using it. And as soon as we stopped using it, when we hit the end here, this variable disappeared.
So then how do we do that without, I mean, without it disappearing?
You can't.
Okay, so then.
I mean, if you, okay, I think I see what you're saying. I could have done this. I could have said int sum like this.
Yeah.
And then I could have said sum is equal to that. Now I can print out sum up there.
Okay.
But this would be very bad programming practice, because now what I've done is I've created a variable called sum
Yeah.
that is global in my entire program.
Okay.
It was actually born outside of main. So it's accessible in main, in add nums, and do something. All right. So really the way I have this written is I'm only using sum for this very short period of time.
But you could put C out answer, and that would give you the answer.
Correct. Yeah, because the answer is in the scope of this.
So that it goes, okay.
But keep in mind, if I wrote it this way, I could technically make add nums void. I don't actually have to return a value. I can make this guy void, because now what does add nums do? It just sets a global variable equal to something. Pretty bad programming practice. Works, but not really what we intend for this guy to do. Go ahead. Let me show it to you with a second call. I'm going to call my add nums function 2 separate times. The first time I'm calling it, add nums then returns a value, which I'm capturing inside this variable. I'm then printing the value that it was returned. Then I'm calling add nums another time, a second completely discrete call from the first one. In fact, the first one died. This one ended as soon as I got my answer out of it. So now I'm calling add nums again. 13 comes in for the 8, 20 or for the A, 28 comes in for the B. It's going to add them together, storing the result in sum. Now I'm returning sum. Returning sum, you can think of it as kind of firing it out the back end here. All right, as an int, sum is an int. It's adding two numbers together, storing the result in sum. I'm returning what I promised I would return. It's now firing out of here, and I'm catching it in this. So now when I print out answer, I'm printing out whatever add nums returned for 13 and 28. Where up here, I printed out whatever add nums returned for 5 and 7. So I'm getting the result of add nums, because add nums doesn't just do something. Add nums does something and then returns the result of what it did. It's giving me an answer. Okay, so we can think of add num, we can think of return as kind of like that toaster. When I put the toast and I hit the button, after a few minutes, it returns toast. And now I have toast, I'm going to go and eat it and do whatever I'm going to do with the toast. Make sense? So that's what return statements do in our functions. But we would generically say this. Return makes a function immediately end. All right, that's an important caveat here, because we'll just say note. We can use return to end a function early without actually returning a value. Let me see if I can show you an example here with our do something. I can throw return in there, not returning a value. Now what happens is do something starts running. Number of times will be 5 or 100, whatever I put in there. It's going to do something. Let's say it was 100. It's going to do this 100 times. So it's going to do this stuff 100 times. Then we have this inner loop that says I'm going to do this 9 times or 10 times. I print out a 0, and then I immediately end the function. So I don't actually do stuff 100 times. I don't actually do 10 things 100 different times. I do this exactly one time, and then I kill the function, because the return statement makes the function immediately end. That's what that tool does. Okay. It's not very smart to use it in this case, because now my code doesn't do what I wanted it to do anymore. But that's what return does, is it makes a function end. Now I could, and if you want to see that, we'll go ahead and call do something. I'll pass it a huge number, and we're going to see that it'll only spit out a 0. There's my 0. And it printed the 0 because J started off at 0. Is 0 less or equal to 9? Yes, it is. Print out a 0, kill the function. Done. It's not going to spin up again. It's not going to go to the next iteration through the for loop. This function died. All right, so we understand that use of return. Return isn't just used to give a value out. It kills a function immediately, but has the possible extra ability of carrying a result out with it. Now, what if I say return 14 here? Now I'm inside of a function that I've advertised as not returning anything. Void functions are functions that don't return a value. I probably am writing them with the intent that they are going to do something but not return something. So now I am breaking protocol here. I've advertised that I won't be returning anything, but now I'm trying to return something. It's yelling at us return statement with the value in function returning void. C++ is saying, look, you told me you won't return anything, yet you're returning something. One of two things is true. you either meant to return something and didn't advertise the function as returning something, or you're accidentally returning a value here that you don't want to be returning. But understand that you can use return without a value, and that just makes a function end. All right, that makes some sense? Go ahead. Because we advertised that it's going to return an int. Yeah, we didn't have a void up there. This function, we said, look, you're returning an integer. So now if we didn't return it, it would yell at us. Okay. All right. So I'll write up the homework in on Blackboard, but what I'm going to have you do is another fairly simple logic puzzle, similar to what we did with the do something 100 times or print out all the numbers between even and odd, but it's going to be encased in a function and then have you call that function. All right. So more practice with the stuff we've already been doing, but now in the context of functions. I'll put this code up on, actually, I'll just put this as shared code so you have it.